In our lesson today, we're going to have practice factoring polynomials. And before we actually jump into factoring, we're going to do a quick review of multiplying polynomials. We're going to use the distributive property to multiply the following monomials and polynomials. And it's important to remember that when multiplying, you're going to add the exponents. So I'm going to multiply 3x by 4x squared minus 6x plus 2. So this 3x is going to multiply each part of the second polynomial in parentheses. So I'm going to do 3x times 4x squared, which is going to be 12x to the third. And then I'm going to do 3x times negative 6x, which is going to be negative 18x squared. And then I'm going to do 3x times positive 2, which is going to be positive 6x. Okay, in this next example, I have a binomial multiplying another binomial, and so I'm going to multiply 2x by both terms in the second polynomial, and then I'm going to multiply 1 by both terms in the second polynomial. So 2x times x is 2x squared. 2x times 3 is 6x. Then I'm going to do 1 times x, which is just 1x, and then 1 times 3, which is 3. And now I can see that I can combine the 6x and the 1x, so I'm going to have a final answer of 2x squared plus 7x plus 3. In the next example, I've got this binomial and it's being squared, and so it means x plus 2 squared means I'm going to do x plus 2 times x plus 2, and so I'm going to be multiplying very similar to the way that I just did in example number 2. I'm going to start with x times x, which is x squared, x times 2, which is 2x, and then 2 times x, which again is 2x. 2 times 2 gives me 4. I can combine 2x and 2x, so I'm going to have a final answer of x squared plus 4x plus 4. In example 4, they tell us the length of a rectangle is represented by x plus 3, and the width is represented by x minus 4. Represent the area of the rectangle in terms of x. To find the area of a rectangle, we do length times width. So we have the length of x plus 3 times the width of x minus 4. And again, I'm just going to multiply these two binomials together. X times x is x squared. X times negative 4 is negative 4x. 3 times x is 3x. 3 times negative 4 is negative 12. And then when we combine the negative 4x with the positive 3x, I'm going to end up with a final answer of x squared minus 1x, or just minus x, and then minus 12. In the next section, we're going to practice factoring. Factoring is the reverse of multiplication. It means breaking a polynomial into 2 or more parts, which again are called its factors. And we're going to start our practice by factoring out the greatest common factor. The greatest common factor is the greatest number or expression that's a factor of 2 or more numbers or expressions. What we're going to do, our steps, in the first step, we're going to find the largest number and variable with the highest exponent that can be divided evenly into each term. That will be our GCF. We write the GCF outside of the parentheses, and then we divide each term by the GCF. All right, write the results as a polynomial listed inside of the parentheses, and then we could always check our answer by distributing the GCF just like we were doing earlier. Okay, so in our first example, we have 2x squared plus 2x. Okay, looking at both of these terms here, I see that they have the number 2 in common, and they have the variable x in common, and so I can use 2x as my GCF. Now I'm going to divide each term by 2x. If you do 2x squared divided by 2x, that leaves you with x. And then if you do 2x divided by 2x, that leaves you with 1. So I'm going to have x plus 1 inside of the parentheses, and I have successfully factored out the GCF. In example 2, I'm looking at my terms here, and I see that they have the number 12 that can be a factor, but they also have a to the second power that can be a factor. Okay, so I'm going to use 12a to the second power as my GCF. When I divide 12a squared by 12a squared, that leaves me with 1. And then when I divide negative 24a to the third divided by 12a squared, that's going to leave me with negative, so minus 2a. In the next example, I see that these two terms have a variable x in common, and they have a variable y in common, so I'm going to use xy as my GCF. And now when I divide x cubed y by xy, that's going to leave me with just x squared. And when I divide 4xy to the second divided by xy, well, that's going to leave me with 4y. And so I get the example of the answer xy times x squared plus 4y. In the next section, we have an application of factoring. We have a rectangle whose area is 3a squared plus 3a, and I want to find expressions for the dimensions, which are the length and the width of our rectangle. Now, there's more than one possible solution. The first thing I can do is take the area, 3a squared plus 3a, and I can notice that they both have the number 3 in common. So I can just factor out the 3, which is going to leave me inside of the parentheses with a squared plus a. Okay? But I could also look at this example, 3a squared plus 3a, and realize that they have a variable a in common. So I could divide out an a. 3a squared divided by a is 3a. And then 3a divided by a is just 3. So I would end up with a times 3a plus 3. Okay, but the third way, and probably the best way to do this, would be if we were to factor out the greatest common factor. And looking at both terms here, they have a 3 and an a in common, so 3a would be my GCF. 3a squared divided by 3a is going to be left with a, and then when I divide 3a divided by itself, that leaves me with positive 1, and so I could have 3a times a plus 1. In each case, one of the factors would be the length, and the other factor would be the width. Factoring out the GCF can be very useful when we try to factor certain polynomials. For example, if I have 3x squared minus 9x and I wanted to factor out the GCF, well, again, I'm just going to practice doing what I did before. I look at both terms, and I realize that 3x would be the GCF. And so now when I divide, I'm going to be left with x minus 3. And in this polynomial, I have 2x minus 6. I look at both terms. I realize that they have a number 2 in common. And when I divide both of those by 2, I'm going to be left with x minus 3. Okay, and this is going to be useful because now I'm going to put both of these polynomials together as one example. So I have 3x squared minus 9x plus 2x minus 6. And I want to factor this entire polynomial. And the way that I'm going to do that is I'm going to break it into the terms that we started with up here. I'm going to break it into 3x squared minus 9x, and then I'm going to have 2x minus 6 in my second set of parentheses. And what I'm going to do for each one of these pairs, I'm going to factor out their GCF. With this first set, it was 3x times x minus 3. And with the second set, it was 2 times x minus 3. Notice when I factor out the GCF that they both have x minus 3 in parentheses. That means that x minus 3 becomes one of the factors, and my other factor is left over with what the GCF was for each pair, 3x and positive 2. 3x plus 2 becomes my other factor. And so by breaking these up into two different problems where I can factor out the GCF, I'm able to factor an entire polynomial. So in example number 3, I'm going to try that. All right, I have 4x squared minus 4x plus 3x minus 3. And I'm going to treat this as two different problems. In my first set of parentheses, I have 4x squared minus 4x. And I'm going to factor out their GCF. The GCF here is going to be 4x. And when I factor out the 4x, that's going to leave me in parentheses with x minus 1. With my second set of parentheses, looking at these two terms, the GCF is positive 3. And when I factor out the positive 3 inside of the parentheses, that's going to leave me with x minus 1. And so now when I write this in factored form, notice that my one factor is the x minus 1. And my second factor is going to be the GCFs, 4x plus 3. Okay, in example 2, we have 2x squared plus 10x minus 4x minus 20. And again, I'm going to break this up into two different problems. With the first set, 2x squared plus 10x, the GCF is going to be 2x. When I divide both terms by 2x, that leaves me with x plus 5. In the second set of parentheses, negative 4x minus 20, I'm going to use negative 4 as my GCF. And that's going to leave me, when I do the division, with x plus 5 again. And so my first factor, I can use x plus 5. And my second factor with the GCFs, it's going to be 2x minus 4. In our next set of problems, we're going to practice factoring standard quadratics. Okay, and we're told down here that the standard form of a quadratic expression is ax squared plus bx plus c, where a, b, and c are real numbers. Okay, and so looking at this example, 3x squared minus 4x plus 6, a is equal to 3, b is equal to negative 4, and c is equal to 6. Okay, so looking at our three examples underneath, we're going to practice figuring out the values of a, b, and c. In this first example, x squared, there's a coefficient of 1 there, so a is equal to 1. Our middle term, our b term, is equal, our b value is a positive 2. And with our constant term at the end here, c is equal to negative 11. In the next example, our x squared term, the value of a is 2. Notice that we don't have an x term in the middle, so the value of b is just going to be 0. And our constant term at the end, c, is equal to negative 5. With our last example, this one kind of looks backwards from how we're used to seeing it. Our x squared term is down here at the end. Its coefficient is negative 3, so a is negative 3. Our b term is a negative 2 with the x there. B is negative 2. And our constant is the value of positive 5. Being able to identify your a, b, and c values is going to help us factor a quadratic. In this example, we have x squared plus x minus 12. The value of a is 1, the value of b is 1, and the value of c is negative 12. And to help us do the factoring, the first thing we're going to do is find the value of a times c. 1 times negative 12, well, that comes out to be negative 12. The next thing we're going to do is find all the factor pairs for negative 12. 1 times negative 12, negative 1 times 12, 2 times negative 6, negative 2 times 6, 3 times negative 4, and negative 3 times 4 all have a product of negative 12. We're looking for a pair whose sum is the b term of positive 1. In this case, it has to be negative 3 and positive 4 because negative 3 plus 4 is equal to 1. Okay, so what we're going to do is rewrite the expression now. Okay, I'm going to have my x squared, and I'm going to have my minus 12 at the end, but I'm going to rewrite that middle term instead of just positive 1x. I'm going to write it as minus 3x plus 4x, and again, that's coming from this fact right here. Then I'm going to factor by grouping, which I was doing earlier. I'm going to take this and I'm going to break it up into two different problems, and I'm going to factor out their GCF. Once I factor out their GCF, I can see that they have an x minus 3 as a factor, and then the x and the positive 4, which were the GCFs, become the other factor. In example 2, we have 6x squared plus 5x minus 6. And again, we're going to identify a, b, and c. A is equal to 6, b is equal to 5, and c is equal to negative 6. And now we're going to do a times c. 6 times negative 6. 6 times negative 6 is equal to negative 36. And so now we're going to find all the factor pairs of negative 36. So we have 36 times negative 1. We have negative 36 times 1. We have 18 times negative 2 and negative 18 times 2. We have 12 times negative 3 and negative 12 times 3. We have 9 times negative 4 and negative 9 times 4. And the last one we have is 6 times negative 6. And I'm going to look for the factor pair that's going to have a sum equal to the b term of positive 5. In this case, it's going to be 9 and negative 4. 9 plus negative 4 is equal to 5. And so now I'm ready to rewrite my quadratic from above. I'm going to keep 6x squared, and I'm going to keep minus 6 at the end, but instead of plus 5x, I'm going to rewrite that as plus 9x minus 4x. Okay? And now I'm going to factor by grouping. So I'm going to break it up into two different examples here, and I'm going to factor out their GCF. The GCF of the first term is equal to 3x, and when I divide both of these by 3x, that leaves me with 2x plus 3. And now with the last set, I'm going to factor out their GCF, which is going to be a negative 2. And when I divide both of those by negative 2, that leaves me with 2x plus 3. So I can see here that 2x plus 3 is going to be a factor. And my other factor is the GCFs of 3x minus 2.